So yesterday I called like an intro to 6.2. Today I call our day one. So we're going to start talking about the unit circle. The unit circle, in its definition, it is a circle centered at 0, 0 with a radius equal to 1. It's a beautiful, beautiful radius that has 17 angles intersecting the circle at 17 points or ordered pairs. So guys, you have 1, 2, 3, 4, 5, 6, 17 angles if you include 0 and 2 pi as two separate angles. And then you have 17 ordered pairs that those angles intersect the circle at, okay? The unit circle will be a helpful tool that we will use to redefine the trig functions so we can apply it to angles of any size. And it also is going to help us remember the trig ratios for special angle measures. So guys, if you take a peek in degrees real quick, the only angles that we have labeled on the unit circle, because obviously there's other angles too, but they're not labeled, 30, 45, 60, 90, 120, 135, 150. We only label the specials, 30, 45, 60, and multiples of them. They're the only ones that make it onto the unit circle, okay? I hope over the next couple days, maybe even today, you will understand what these 17 ordered pairs are representing for each angle. And maybe you already remember from last year, that's even better. But this is just, it's basically a cheat sheet for problems that we're going to answer in the future. So if you could really easily whip one up, normally you're in school, so you'd have to draw one. You can't just be at home and Google it or take the one that I gave you. But either way, if you could construct one, then you have a lot of answers that we're going to need in the future at your disposal, okay? All right, we're not even going to construct it today. I just want to get you guys starting to understand what it represents. So here we go. We're going to do trig on the coordinate plane. This is how we were able to redefine the trigonometric ratios, sine, cosine, tangent, and the reciprocals to apply to angles of any size, not just angles that fit inside of a right triangle. All right, so we're going to start with a circle centered at 0, 0 with a radius of r. So technically, we're not even talking about the unit circle yet. The radius could be anything, all right? Now draw an angle whose terminal side intersects the circle at a point xy. So guys, let's give ourselves an angle, and let's keep it simple. Let's keep it in quadrant 1. And then it will intersect the circle at a point xy. Okay? And now this is our angle. Let's call him theta. I think our book calls it t. They always use t as the angle because they're going to talk about it in radians as some real number measurement, not degrees. So I think they use t a lot, but I'm so used to theta. All right, now we're going to drop a perpendicular line down to the x-axis and construct a right triangle. So now this is our triangle, or right triangle, that fits inside this circle. Well, guys, if it met the circle at the point xy, what's this distance from here to here? What's that side length, if you will? X. I went x to the right. That's x units. So the length of this side of that right triangle is x units. And then what's this side? How many units big is this side of the right triangle? It would be y units. And then what do we call the distance from center to side on every circle? That would be the radius, right? Okay. So now you've labeled a right triangle using an x coordinate, a y coordinate, and a radius, which is exactly what I told you we would be using to redefine the trig functions. So guys, now go ahead, find the sine, cosine, and tangent of that angle. The sine of angle theta is going to be equal to O over H, a y coordinate, over a radius. The cosine of angle theta, right? If you think A over H is an x coordinate over a radius. And then the tangent of angle theta, opposite over adjacent. But remember, tangent by definition is literally defined as sine over cosine. So it's O over H over A over H, which becomes O over A. So it would be Y over X. And there you have it. Now, all we're technically going to need in the future to find the sine, cosine, and tangent of an angle, and remember, the reciprocals are just the reciprocals of these ratios, is an x-coordinate, a y-coordinate of an angle meeting a circle, and the circle's radius. So technically, you shouldn't need a right triangle anymore. You just need the point the angle meets the circle at, his x-coordinate, his y-coordinate, and the radius now become your trig ratios. So the trig ratios become the ratios y over r, x over r, and y over x. So again, we have redefined them from O, H, A, H, O, A, and now we're using x coordinates, y coordinates, and a radius of an angle meeting a circle. Okay? All right. So the big question is, what if the radius was 1? What if the radius was the nicest number in the world to divide by? What if it was 1? So come down here. Oh, I don't want to move that, but I have to. Oh, well, that's okay. Forward. So guys, if the radius was 1, the distance from center to side, again, give yourself that angle in quadrant 1. The distance from center to side is 1 now. It meets the circle at the point xy still, so it's still xy. So now, on a unit circle, where the radius is 1 unit long, what's the cosine of angle theta? The cosine is x over r. Well, guys, that's x over 1. So what is that? It's x. So that means when an angle meets the unit circle, the x-coordinate of that point literally represents his cosine. So guys, on that entire unit circle, every single x-coordinate represents the cosine of that angle. All right, what about the sine of angle theta? The sine would be y over 1, which is just y. So that means just the y-coordinate on the unit circle represents the sine of all of those angles. And then the tangent, again, by definition, is sine over cosine, or O over A. It's a y-coordinate over an x-coordinate. So you can always make the tangent by putting your sine over your cosine, your y over your x. So guys, that means on the unit circle, if I can go back, if I asked you, hey guys, what's the cosine of 2 pi over 3? There's 2 pi over 3. There's his x-coordinate. The cosine of 2 pi over 3 is negative 1/2. All of these x-coordinates are representing the cosine of all of these angles that they meet the circle at. If I said, hey, what's the sine of 7 pi's over 4? Well, there's 7 pi's over 4. The sine is his y-coordinate. It's negative root 2 over 2. So that's what the unit circle does. In the future, you're going to have to know the sines, cosine, tangents of all these special angles by heart. You're supposed to know them without a calculator, because a calculator is going to give you a rounded answer, and we want exact answers. The unit circle stores all of these answers for you. All the x-coordinates are your cosines, all your y-coordinates are your sines, and you can build the tangents just by throwing the y-coordinate over the x-coordinate. And now you know all of these ratios very, very quickly and very, very easily. Truthfully, I'm still a big fan of drawing a special right triangle, 30, 60, 90, and labeling my sides. I just use this to remember if the ratios are positive or negative. Would an x-coordinate be negative in quadrant 2? Yes, so the ratio is negative. Would the y-coordinate be negative in quadrant 4? Yes, so now I know my ratio for sine is negative in quadrant 4. But some students really like the unit circle because, guys, it has every answer on it. Every answer I'm going to ask you is on that circle. The only thing I call myself a unit circler for are my quadrantals, my 0, 90, 180, 270, and 360. Because those are angles that you technically, literally cannot construct a triangle for, but because we've redefined the trig ratios to be x-coordinates and y-coordinates and y's over x's and radiuses, now I know, oh, what's the cosine of 0 degrees? 0 degrees don't fit in a triangle. You're right, but the x-coordinate is 1, so the cosine of 0 degrees is 1. the sine of 0 degrees is 0. So I only really use the unit circle for my quadrantals. Everything else I can kind of figure out based off what I know about a right triangle and x and y coordinates in each quadrant. Okay, so that's it, guys. I hope you guys realize that this unit circle holds a lot of information, a lot of cosines and a lot of sines of special angles. But that's it. That's all it does. So tomorrow I'll show you how to construct one from scratch. Just ever case in the future when we're not in virtual school and you needed to whip one up on a test, you could do that. Okay. I'm going to leave that there. So let me go to these two. I'm going to fill this in at the end because, guys, I still use that and I'm going to say it a lot, so I want you to know what the hell I'm talking about when I say it, but I'm going to fill it in at the end. So let's go to quadrant 1. We just did it. I want you guys to realize something. If you are an angle that lands in quadrant 1 on the unit circle, then you're going to meet the circle at some point x, y, because you're in quadrant 1. X will be positive, y will be positive. So now, and you have a radius of 1, right? Sometimes, if you want to draw the circle, go ahead. The triangle, you shouldn't need it. The cosine of an angle in quadrant 1 will be x over 1. It's the x coordinate. We just found that out. On the unit circle, the x coordinate is your cosine. The sine of an angle in quadrant 1 will be y over 1, which is just the y coordinate. And since the y coordinate is positive in quadrant 1, it's a positive ratio. And then the tangent, which is O over A or sine over cosine, it's y over x. It's going to be a positive y coordinate over a positive x coordinate. So for any angle that lands in quadrant 1, it's going to have a positive x and a positive y. So all trig functions ratios are positive numbers or positive values in quadrant 1. Or they have a positive ratio, whatever the English grammar correct way of me saying that is. All trig functions ratios are positive in quadrant 1. I guess I can keep the they are. All right, let's go to quadrant 2. If you are an angle that landed in quadrant 2, technically you don't fit inside a right triangle, but your reference angle does, right? But remember, we technically don't need a right triangle anymore to find sines, cosines, and tangents. We need x coordinates, y coordinates, and a radius. Well, guys, we're on the unit circle, so the radius is 1. If you are a point that landed in quadrant 2, you're going to have a negative x coordinate and a positive y coordinate. And again, if you're a visual guy, your reference angle is the one we are fitting inside the right triangle. But because we're on a coordinate plane, this distance is negative x, and this distance, I shouldn't even say it's distance, this side is y, just if you want to give it a label. All right, so now in quadrant 2, if you wanted to find the cosine of angle theta, it's literally the x coordinate over the radius, but the x coordinate is negative in quadrant 2. So now your cosine ratio is going to be a negative number for an angle that lands in quadrant 2. The sine of angle theta would be y over 1, which is just y. So now you're going to have a positive ratio for the sine of any angle that lands in quadrant 2. And then the tangent, sine over cosine, that's a y over a negative x. The tangent of any angle landing in quadrant 2 should be a negative ratio. Because if you do know your right triangles, so one thing you're going to need to know is, is my ratio positive or negative? You got to know what quadrant you're in, and you got to know your x and y's, and then you'll know if your ratio should be positive or negative. So if you look here, the only trig function that gets you a positive ratio in quadrant 2 is sine. So only sine ratio is positive in quadrant 2 because it's a y coordinate, and only the y coordinate is positive in quadrant 2. All right, I got to move mine up. All right, let's say you're an angle that landed in quadrant 3. You're going to hit the circle at a point negative x, negative y, because you're in quadrant 3. Down, left and down. All right, again, your angle doesn't fit inside the right triangle, but his reference angle does. All right? So now if I was to take, if you want to label it, that's a negative x, that's a negative y, and then your radius is 1. If you were to find the cosine now, the cosine would be negative x over 1, which is negative x. So it's going to be a negative ratio for an angle in quadrant 3. The sine is going to be O over h, or negative y over 1. It's negative y. So the sine of any angle that lands in quadrant 3 is going to have a negative ratio. And then the tangent, sine over cosine, that's negative y over negative x, which reduces to a positive. So the only trig function that will produce a positive ratio for any angle in quadrant 3 is tangent. And you could be sitting here thinking like, this is important because you got to know where things land, and you're going to need to know if your ratios are positive or negative. But as long as you can picture an x and a y coordinate, you shouldn't have a problem. All right, if you're an angle that lands in quadrant 4, you are going to intersect the circle at some point x, negative y. If you wanted to construct a right triangle, the reference angle fits, and then this would be x, 1, negative y. If you want to label it, some people like to visual it, but you really don't need a right triangle anymore. All right, this cosine would be x over r, which is just x. So the cosine of any angle that landed in quadrant 4 will be a positive ratio, a positive x value. The sine of an angle that landed in quadrant 4 will be negative y over 1, which is negative y. So it'll be a negative ratio for any angle that you take the sine of that landed in quadrant 4. And then tangent, again, sine over cosine, that's negative y over x. So look who only gets you a positive ratio for an angle in quadrant 4. Only cosine. Only the cosine ratio produces you a positive ratio in quadrant 4. Okay, so there's a little like fun, please excuse my dear Aunt Sally, whatever those things are called. There's a little fun saying that helps you remember where everything is positive or negative. Again, as long as you know where an x coordinate is positive, you know where cosine is positive. As long as you know where a y coordinate is positive, you know where sine is positive, and vice versa for negatives. All right, but if you go back up to the top, the fun little saying that I will say all the time because I still use it is, quadrant 1 was what? X, y, right? Negative x, y, negative x, negative y, x, negative y. And we've learned that cosine is x and sine is y. And tangent is y over x. We already filled that in. Okay. Well, guys, the saying is all students take calculus. And then I always put a little plus next to it. So all students take calculus says all trig functions ratios are positive for angles in quadrant 1. Only the sine ratio is positive for angles in quadrant 2 because only the y coordinate is positive. Only the tangent function gets you a positive ratio for angles in quadrant 3 because it would be a negative y over a negative x and reduces to a positive. And then only the cosine function gets you a positive ratio for angles in quadrant 4 because it's the x coordinate and that's where x is positive. So all students take calculus. It's supposed to help you remember where the ratios for each trig function are positive and where they are negative. So guys, please take note. Each trig function is positive, has positive ratios in 2 quadrants, and negative ratios in 2 quadrants. Sine is positive in 1 and 2, but it's negative in 3 and 4. Cosine is positive in 1 and 4, but it's negative in 2 and 3. Tangent is positive in 1 and 3, but it's negative in 2 and 4. So just keep remembering that, okay? All right, so let's try and do one problem before the bell cuts me off. I might finish a set of notes. So guys, I gave you, and I don't even know if I posted it yet, I apologize. I gave you an extremely short, hopefully, homework today. It's only 4 or 5 problems, just like this one. I didn't know if I'd get to the example, so I didn't post the homework yet. All right, here we go. For homework, this is what you're gonna have to do. Are you okay with that? Yeah. Stretch, do what you gotta do, walk around. Find the exact values of the trigonometric functions using a point on the unit circle. Guys, it's a point on the unit circle. So what do we know the x-coordinate of this point represents? It's cosine. And what do we know its sine, or what do we know its y-coordinate represents? It's sine. And then his tangent can always be built by putting his y-coordinate over his x-coordinate. All right, but guys, you gotta be careful because they give you problems like this, not today, but it'll just say P is a point on a circle. Then, does his x-coordinate and y-coordinate represent his sine and cosine? No, it has to be the unit circle for just the x-coordinate and just the y-coordinate. All right, so guys, it's a point on the unit circle. Be a point, and that corresponds to t. So t is our angle measured in radians as a real number. Find the value of the following. So guys, if this is the point, it meets the unit circle. If this is his x-coordinate and y-coordinate, then guess what? This is his cosine of angle t, they call t, yep, and this is the sine of angle t. So what's the answer to the first question? What's the sine of angle t? His y-coordinate is 2 root 6 over 5. Done. What is the cosine of angle t? What's his x-coordinate? Negative 1/5. And then tangent, you're always going to work a little bit harder for tangent. Remember, tangent by definition is sine over cosine, right? Which the sine is y, the cosine is x. So it's y over x. So take the y-coordinate, 2 root 6 over 5, and throw it over the x-coordinate, negative 1/5. So we have a complex fraction. We have fractions within a fraction. So I'm just going to multiply by the bottom's reciprocal. Clear him out of there. All right, my 5s will cancel. I'm going to get 2 root 6 times negative 1. That's negative 2 root 6. Okay, now, to get the reciprocal trig functions, cosecant is the reciprocal of sine. So guys, technically, he's 1 over the sine of angle t. By definition, he's the reciprocal. So you could do 1 over the y-coordinate, or guys, just flip over sine. It's his reciprocal. So he's going to be 5 over 2 root 6. But now we got to rationalize, right? So it's multiplied top and bottom by root 6. I'm going to get 5 root 6 over, what's root 6 times root 6? Just 6. 6 times 2 is 12. 5 and 12 don't reduce, so you're good to go. All right, secant. It is, by definition, 1 over the cosine. So you could do 1 over negative 1/5, or flip him over. It's his reciprocal. It's negative 5. And then the cotangent, by definition, is now cosine over sine, or 1 over the tangent, or guys, flip that over. It's his reciprocal. And then we'll just times top and bottom by root 6. And you'll get negative root 6 over root 6 times root 6 is 6. 6 times 2 is 12. I just put the negative on top. And you're good. So if they're going to gift you a point on the unit circle and they start asking you trig ratios, guys, it's x-coordinate is cosine, y-coordinate is sine. Now, just for those of you who are visual people, guys, it intersected a circle at the point negative 1/5 and then 2 root 6 over 5. So that must have been a point or an angle in quadrant 2 because it was negative 1/5 and then 2 root 6 over 5. And then if you wanted to construct a triangle, go ahead. This is negative 1/5, this is 2 root 6 over 5, and that's a radius of 1. And now you have a triangle if you want it, and you're in the correct quadrant. And guys, all students take calculus, right? All students, only the sine ratio and his reciprocal should be positive, and they are. All the other trig ratios should be negative, and they are, okay? All right, how do you guys feel? Is everybody good? All right, so if you're a point on the unit circle, what does the x-coordinate represent? The what of that angle? The x-coordinate. Cosine? If you are a point on the unit circle, what does the y-coordinate represent for that angle? the sine, and then the tangent is y over x, okay? So there you have it. Okay, so tomorrow, so you have a really short homework assignment tonight on this, and then tomorrow I'm gonna hopefully try breaking the unit circle down a little bit, so if you ever want to construct it, and then we're gonna start using it, and we're gonna start doing all kinds of trig ratios. All right, at home, are we okay? Awesome. All right, so guys, again, you have a short, I say short, I mean, it's this, I think 4 or 5 times, so hopefully that's not too long. And that is due, I made it due tomorrow night, okay? All right, let me take your attendance, and then you guys should be good to go. Unless you have any questions, please feel free to stay and ask.